Hello everyone, this is a little test to see if this even works. So I'm going to go through your homework paper, literally just a test. So this was question 1, and hopefully it's going to pick this up. So the question says, find the gradient of the straight line drawn on this grid. Now the first thing to notice is it's going up. So your answer is going to be a positive number. And then there is one kind of key formula that you need to remember, and that is gradient equals, so this, as I say, I've only just got this, so this will only improve, I'm sure. So the gradient is how far up divided by how far along. Remember, we measure along going from left to right. And then if it's actually going down, it's kind of like a negative up. So you end up with a negative answer when you divide by the along. But anyway, you could measure from anywhere. There's nothing special about any particular coordinate. But you want to pick some easy coordinates. So for example, if you pick this one and this one, they go through two whole numbers. And so you're literally just going to go, okay, well, that's 2 along, right? Remember, we're going from left to right, and then it's going 3 up. So 3. So you're going to have equals 3 over 2, which is just 1.5. I guess if you want to skip to the next question, look in the timestamp. I'll just say something extra about this one. There is nothing special about picking these coordinates. You could pick, for example, I could have picked, well, let's stick with this one, but I could go like along 4. And then where am I going up? I'm going up 6. Is really, so 6 up, 4 along, and the idea is well, it's the same thing as 6 over 4. Okay, so it just doesn't matter. You could pick any random coordinates actually, and for every one you go along, you go 1.5 up. Right, next question. Okay, so to do a frequency polygon, you go, so this was something we've done maybe in year 9 or yeah, I think in year 9 for sure. You were taught that, okay, you go halfway between 0 and 10, and then you go up to 6, and so you plot a coordinate there. But halfway between 10 and 20, go up to 9. Halfway between 20 and 30, and go up to 8. Halfway between 30 and 40, 7. And halfway between 40 and 50, 5. And then the way you do this, and this is not going to be very easy unless I can use this. Oh, no. So you would need to use a ruler realistically. Not sure how I move this or rotate it. Oh, it keeps going forever. Okay. Anyway, let's not use that. That seems a bit tricky. What have you got to do? Well, you've got to join these up, ideally with a ruler, but I don't have a ruler, so you're just going to have to bear with me. Join them up with a straight line, so apologies for this, but there you go. Join them up with a straight line. And then that's it. You don't join them up at the bottom. You don't go down. That's the final answer. Okay, so you get a mark if you plotted these coordinates, and you get a mark if you join them up correctly, but you'd lose 1 mark if you made a mistake. For example, if I do that, well, that's wrong. You shouldn't do that. Okay, and I'll say one more time, yeah, that should have all been done with a ruler. Okay, number 3. So we're comparing prices. So Henry's thinking about having a water meter, and he can either pay £107 per year, or he can pay £28.20 a year, but then he's going to get charged for however much water he's going to use, and he gets charged 91.22 pence. So that's going to go into the decimals of pence, but because he's going to use a lot of it, well, it'll times by a big number, and it will actually make some difference. They'll obviously round the final answer before they give him his bill. So anyway, it says he gets charged 91.22 pence for every cubic meter of water used, and the question even is so kind as to tell you that that is 1,000 litres. Okay, so every time he uses 1,000 litres, he gets charged £0.91.22 pence. So then it tells you, okay, Henry uses an average of 180 litres of water each day. So the first thing that comes to my mind is all of this is to do with it's a yearly charge he's going to be asked for. You know, once a year he gets given a cost, and he's either going to be no water meter with £107, or he's going to be charged based off of using 180 litres of water each day. So let's work out how much he would use if he for the whole year, right? Like, that's a good start. So let's just get this up. Oh, I'm not sure what's kind of going on there. There we go, right, sorted. Okay, so he uses 180 litres of water each day. So let's do 180 times 365. I think we're going to be allowed to forget about leap years, but if you wanted to, I think, you know, it doesn't really matter. The question allows you to use 365 days or 366 days or whatever you want to account for a leap year. I'm just going to use 365 days. So anyway, he uses, so let's write this down. He, and this is where it really is not very easy because I'm not used to using this. He uses 65,700 litres per year. Right, so how many cubic meters is that? Because that's what he's going to get charged 91.22 pence every time he uses a cubic meter. So I just need to divide that by 1,000, because 1,000 litres, every time you've got 1,000 litres, you've got 1 cubic meter. So if you've got 65,700 litres, I'll divide that by 1,000 and get that is 65.7 cubic meters. And he gets charged 91.22 pence. So let me write it like this: multiplied by because it's in pounds, right? That's in pounds. The charge for the £28.20, the £107 is in pounds. So let's convert this to pounds. So this is £0.9122, because he gets charged that much money for every cubic meter he uses. So I need to use a calculator to do 65.7 times 0.9122. So just to clarify, this is how many cubic meters he's using in a year, which was how many litres he was using in a year divided by 1,000. And this is the cost in pounds for each one of those cubic meters that he uses. So that is, well, after rounding, because the water company is going to have to round this to £59.93. So let me write that, if I can, here, £59.93. But then I'll need to do because he gets charged £28.20 on top of that, doesn't he? So £28.20 plus £59.93 is his overall cost. We can already kind of see, can't we? It's going to be less than 107. So on the calculator, because we've got a calculator, might as well use it. 59.93 add £28.20. So you get that's £88. £88.13. So therefore, you should have a water meter. This little 3 dots like this, that's just shorthand for therefore. That's not just a maths thing. You would see that in other subjects as well. I mean, probably not English, to be fair, because they probably want you to write the full word. But certainly here, I can just go ... meaning in that pattern there, and that means therefore. So water meter should be chosen, right? Now, you don't actually get the final mark. You don't get the 5th mark if you don't write a little conclusion. And that's something a lot of people kind of forget about. They do the calculation, they get the £88.13 and don't then get the final mark because they don't actually write a conclusion. Now, for anyone who's going to be a little bit pedantic, how do we know he definitely should choose this? Well, it actually says in the question, doesn't it? Henry wants to pay as little as possible. So we're going to go £88.13. Okay, let's look at the next question. Right, number 4. Okay, Kalinda pays on tariff A for the number of units of electricity that she uses. So again, this is a little bit like the last question, okay? Kalinda uses some electricity, and electricity is then charged for based on how much she's obviously used. So she's going to use this graph here to find out how much she's going to pay. So how much does Kalinda pay for each unit of electricity she uses up to a total of 60 units? Okay, so let's look at 60 and how much she would get charged for 60 units. Now that to me looks like £15. So she'd get charged £15 if she used 60 units, right? That's what she would be charged. I would go, put a dotted line going up and a dotted line going across, but I don't trust myself. I'll try with this. No, that's not going to, is that going to work? So 60, oh dear, it's crashed. So we're used to this at school, but not with PowerPoint. Okay, it's fixed itself, right? I must have clicked too many times. I was doing too many dots. Anyway, there you go. So 60 units is £15, and because that's a straight line, that's going up linearly. So what that means is for example, if she used 30 units, well, she's going to get charged £7.50. Right? It just scales like that. So how much does she pay for each unit of electricity she uses? Well, for 60 units, so for 60 units, let's write it here, 60 units would be £15. So how much does she pay for 1 unit? Well, whatever 15 divided by 60 is. Now we can use a calculator, but I can just, 15 over 60 is a quarter, so that's 0.25. But if you're unsure, you just use a calculator. Okay, all I've done is well, 60 divided by 60 is 1. I've got to do 15 divided by 60 and get 25. So that's 25p, isn't it? So 25p. So it's 25p per unit of electricity that she uses. And then, okay, so we've answered that question. Kalinda could change to tariff B. Here is the monthly charge for tariff B. And she's going to get, she's only going to pay 20p per unit of electricity used. Okay. So that seems like it's going to be cheaper, right, on the face of it, because at the moment she's paying 25 pence per unit of electricity. One thing we need to notice though is that the rate that seems to go down after 60, so she starts paying a little bit less per unit for any units over 60. So that's kind of this little bump in the graph where the gradient actually becomes a bit less steep. That's how we would interpret that. But anyway, on average, Kalinda uses 90 units of electricity each month. She wants to pay the least amount of money. Should she change to tariff B? Well, let's first of all work out what she would pay on tariff A. So this isn't going to be the easiest thing in the world, but whoa, that is such a wobbly line. I would love to just be able to put a straight line in. Right, I'll use my mouse instead of this thing. Right, so that's that, and then I go along, and you look closely, I mean, I know it's kind of gone a bit wobbly there, but if you look closely, if you look here, it's just one little square under. So that looks like it would be £19 approximately for tariff A. So how much would it be for tariff B? Well, for tariff B, it would be 90 lots of 20 pence. Okay, so well, again, I don't need to use a calculator for this. This was 9 times 2, which is 18. So yes, right, because it's cheaper than tariff A if she uses 90 units of electricity. So yeah, you have to compare. So the £19 for A, what's the working for that? It's the fact you've drawn that on and shown you've gone to 90 units and along. Should we change to tariff B? Well, that's the working for that. It would be 20p per unit, so 90 times 20p is £18. So yes, you should. I'm just going to double check the mark scheme because with questions like this, it's kind of difficult for me to tell exactly what's written on the screen instead of on a bit of paper. Might as well look at the other questions as well. Okay, well, 1 and 2 are fine. So for number 3, yes, £88.13, and the decision should have a water meter installed. Yes, good. And yeah, we're spot on with number 4 as well. It's 15 divided by 60 is 25p, so you actually get 2 marks for that. And then 3 marks if you do 20p times 90 is £18. And then if you say that from the graph 90 units would have been £19, which is literally exactly what I've done there. So okay, so far so good. Let me just put the mark scheme to one side. I just obviously want to make sure I'm not telling you anything that's wrong, obviously. So let's keep going. Number 5. David is planning his garden. There will be 2 paths in the garden, so there they are. And the rest of the garden will be grass. Now, the first thing I notice is we've obviously got 2 triangles for the grass and a trapezium over here. All measurements on the diagram are given in feet, right? And then we got to work out the total area of the grass. Okay, so let's do the trapezium first of all. So I do, remember I would do 15 add 6. So you add up the 2 parallel sides. You would then times by the distance between them, that perpendicular height, which is 25, and then you'd halve that. Okay, so that's that. I guess we should figure that out since that's going to be part of the question. So we should do 50, well, we can do it separately. So 15 add 6, okay, that's 21, didn't need a calculator, times 25 and then halved. So the area of that part there is 262.5, and we'll worry about the units at the end. But since all the measurements are given in feet, and it's an area, the units are going to end up being feet squared, which is not something you often hear, but that's what it would be. So we're going to have 262.5 for this, and now here's a triangle. Now the formula for the area of a triangle is a half base times height, and that height has to be perpendicular. So that's a height of 25, because it's the same as this. It's the same as the 25 that's on the side. So here I'm going to have 11 times 25 divided by 2. I might as well do this one at the same time and then get the 2 answers. So this is going to be 12 times 25. So I'm just doing a half base times height. So there's the base is 12, the height is 25, and there's the half of it. So let's write the answers in for these then. So we've got 12 times 25 and then halved. So that's 150. I think I'm getting used to using this pen. That's 150. And then 11 times 25 divided by 2 is 137.5. And so we just have to add these three numbers up, right? Because we want the total amount of grass. So 150 add 137.5 add 262.5 is 550. And I'm willing to bet there's an entire mark allotted for writing feet squared. Okay, that's what I'd be willing to bet. So let's have a quick look at the mark scheme. So this is number 5. 550 feet squared. Super, right, great. Let's move on to the next one. If you do have any specific questions, by the way, about any questions, please do just send me an email or let me know in class. This is just one obviously long video. There'll be timestamps in the description. Probably should have said that at the start. I haven't made a video for a while. There'll be timestamps in the description that allow you to skip between questions, so you don't need to sit through obviously the whole question if you know what to do. But yeah, this video is just the entire exam paper. And actually, I started by saying this is a test. I don't actually know if the volume level is going to be all right, but I've kind of just continued on with the whole thing. So let's just hope it is at this point, because I am going to continue. Anyway, here we have an index laws question. So the base is the same, P and P, and we're multiplying, so we're going to add the indices. So that's the rule here. A reminder of why this is, so I will write this down just for anyone who's unsure. So the first part is P times P times P times P times P. Right, that's this bit. And then what am I doing? Well, I'm timesing it by P times P times P times P, right? That's what's happening. And so the final answer is P to the 9. So that's why you add the indices. For some reason it's done that. Let me just undo that. Oh, it fixed itself. Oh, that's clever. Right, okay. So this one I'm dividing. So I take the indices away. So 5 take away 2 is 3. Let me just move that over actually. Should be there. Right, this one. Let me write it as a fraction. You don't need to write it as a fraction to answer the question. But let me just write it as a fraction just to illustrate what's going on. And then what I'm going to do is actually at the side, I'm going to write it a bit differently. So this would actually be, let me just get the calculator off, don't need that anymore. So this would be the product of, because if you think about how do you times fractions together, you just times all the tops and all the bottoms together. So this is how this works, basically. I could just tell you the answer, but let me just show you this. So why have I written this, this part here? So the reason is if you know how to times fractions together, you know you just times all the tops and you times all the bottoms, right? That's the easiest thing to do with fractions, is to times 2 of them together, because you just need your times tables. So anyway, 12 times t times u to the 6 is 12t u to the 6, and 6 times t times u to the 5 is 6t u to the 5. And then the idea is each part will then simplify. So 12 over 6, that part's just 2. T divided by t is 1. Anything divided by itself is 1. And I'm timesing by this. I'm timesing by 1. So I don't need to write it. I don't need to write anything for that. I would if the overall answer was 1. But since I've already got a 2 here, I'm not going to need to write that I'm timesing that by 1. Okay, so t over t. I guess the index law would be that it's t to the 1, t to the 1, and 1 take away 1 is 0. Anything to the power of 0 is 1. I'm not going to need to write this because, because I've got these other parts that I'm timesing. So anyway, what do I do here? Well, this is u to the 6 divided by u to the 5. So I take away the indices. So 6 take away 5 is 1. And u to the 1 is just u. Okay, so that's the answer to that one. And then this one, So this is a power of a product. So here's the product. It's a bunch of things times together. So that's why I'm saying it's a product. And it's a power of that. And the way this works is it becomes the product of individual powers. So you've got 9 to the half times by w squared to the half times by y to the 6 to the half. And then you can work these individual bits out and everything's just being times together. So 9 to the power of a half, let's pretend you don't remember that that means the square root of 9, but you've got a calculator, right? You've got a calculator, so you could go 9 to the power of 1 half and go, oh yes, great, thank you, that's 3, isn't it, right? So anyway, power of a half is a square root, so that's a good thing to remember on the non-calculator paper. But as it happens, it's got a calculator, so you could remind yourself. And then when you've got this kind of thing going on, you multiply the indices together. If it's a power of a power, you multiply the indices. So a half times 2 is just 1. So that's w to the 1, which I don't need to write. And then 6 times a half is 3, or I'm halving 6, which is 3. So this becomes y cubed. Okay. Right, and then this last one. So the best way I have really to explain this is it's telling you x is greater than 1. So just pick a number x could be where you would be able to work these indices out. So it's got to be a square number basically, because I'm going to have to do a square root of it. So let's just pick, for example, so e.g. Let's see if I can get this lined up. X equals 9. Let's pick x is 9, just for the sake of argument. Okay. Now you could pick any square number. In fact, you could pick any number greater than 1, and all of this would still be the case. But I'm going to illustrate it by using x is 9. How did I know that I should use x is 9? Because I know I'm going to need to square root it. Okay, and I want to have a nice answer. And I just need to pick any number that's greater than 1. So anyway, what is x to the power of 0? Well, anything to the power of 0 is 1. What is x squared? Well, 9 squared is 81. So already I can say that x squared is going to be bigger than x to the 0. And if you think about it, even if x was like 1.01, this would be bigger than this. But I'm choosing that x is 9 so that it's easier to illustrate and easier to see. So x is just 9. X to the minus 2. So imagine you forgot what a negative power does. So it's a reciprocal of the positive power. So this will be 1 over 81. Yeah, it'd be 1 over 9 squared. But you have a calculator for this question, so you could just check it out, make sure you get it right. 1 over 81, super. So that's pretty small. In fact, that's smaller than 1. That is smaller than 1 is. So that one will be the one that probably comes first, because the square root of 9 is just 3. So I'm just going to write the answer over here. The smallest one is x to the minus 2, because that's 1 over 81 for us. Then it goes x to the 0. Then it goes x to the half. Then it goes x by itself. And then it goes x squared. And to be fair, you could have had a guess, right? The indices are just going up in order of size, aren't they? Minus 2, 0, then a half, then 1, then 2. So you could have had a guess at that one. Right. Now, I will say one more thing before moving on to the next question. X being greater than 1 it actually is important, because if x was equal to 1, all of these would equal 1 and you wouldn't be able to put them in order. If x was less than 1, say x was a fraction between 0 and 1, you're actually not going to get the same order. And that's actually something which you should investigate. What happens if you pick, for example, x is a quarter? What happens? You get a different order. So the x greater than 1 actually does matter. But as it happens, it gives you the nicest answer where the indices are just going up in order. Right, number 7. Here are 3 cubes, okay, A, B, and C, and we've got the volume of B, so the middle one is 20% less than the volume of A, and the volume of C is 20% less than the volume of B. And it tells us that cube A has a volume of 8,000 centimeters cubed. Okay, well, I'm going to answer this how I would imagine most students would. What I would do is I would just say if this is 100%, this will be 80%, and then I would work out what that is by taking 20% off of 80. I wouldn't even bother with working out the volumes, but I'm going to do that anyway because I'm going to go ahead and assume that's what most people did. So if this one's 8,000, right? I just need to work out what 20% off of 8,000 is. So if you're going to reduce something by 20%, then you're going to be left with 80% of it. So I need 80% of 8,000. And that's where the calculator comes in, right? So 80% as a decimal is just 0.8. Of means times, and then 8,000. So this is 80% of 8,000. And so this is the answer for B. $6,400. Write that again. And then I need 80% of 6,400. That's going to be C's volume, isn't it? So 80% of 6,400. Because if I'm 20% less, then that means I'm left with 80%. So 80% of 6,400 is 5,120. Okay, so we've actually got the volumes now, so that's good. And then let's read what the question says. What is the volume of cube C as a percentage of the volume of cube A? So, okay, so we are out of the volume of cube A, so we are out of the volume of cube A, and the volume of cube C is that, so I just need to write that as a percentage, so I'm going to just times that by 100 and stick a percentage symbol in front and see what I get. So on the calculator, 5,120 divided by 8,000 times by 100, okay, so 64%. There we go. Right, let's do a quick mark scheme check. Yep. Okay, next question. In a sale, normal prices are reduced by 15%. Okay, so we'll be left with 85%. So Janice buys a computer in the sale, which means her number was 85% of the original price. So you really have to, with percentage questions and especially reductions, think of it kind of flipped. What percentage are you left with? Or rather, I guess in this question, Janice, she is left with 85%. So you would go, okay, so 85% was 578. That's the idea. Straight away, we reduced by 15%, so we're left with 85%. So the question is, well, what's 100%? Right, that's the question. And so there's a few ways of doing this. One, you could just use a multiplier. Okay, I could times by 100 and divide by 80. 85, sorry. So, okay, on my calculator, I'm going to do 578, times it by 100, the target, and divide by 85, the start. So, okay, the computer, was 680. So that's the answer. What are some other ways of doing this? Well, if you know 85%, is 578, you could probably work out 5%. So 85 divided by 5 is 17. So if I do 578 divided by 17, that's 34. So 5% is 34. So okay, 10% will be 68. Okay, so 100% will be 680 then. Okay, so there's lots of things, lots of ways of doing it, but they all kind of rely on realizing that 85% is the actual starting percentage, and we know that that's 578, and then from that 85% number, working out what 100% is. So yeah, 680 is the answer to that one. Next question. Number 12. The triangle P is there. Triangle P is reflected in the line x equals -1. Okay, so x equals -1. Think of all the coordinates that you can where the x number is -1. So there's -1, 1. There's -1, 3. There's -1, -3. There's -1, 7. What do they all have in common? Well, they all live on this line. Yeah, that's the line x equals -1. Okay, this is a special case of a straight line graph. Okay, if you have x equals a number, and that's it. Like x equals 4 would just be a straight line like that. X equals I'm just noticing you can't see the mouse move. Okay, let me move it. So x equals 4 would just be a straight line doing that. X equals -5 would be a straight line going like that, vertical. Those are special cases of straight line graphs. If you just get y equals a number, they're kind of the same, but they're horizontal instead. Okay, so anyway, x equals -1 is there, so then we have to reflect this. So that's begins 2 squares away, so it's going to go to here. And then try very hard to draw it nicely. Not the easiest thing to do, but anyway, there you go. So, and then it is reflected in the line y equals 1. Okay, so that's that line. I don't need to draw the whole line because I just need the mirror line here. So that's going to go here then. And that's the triangle Q. And then it says describe fully the single transformation. Okay, so when it says single transformation, you have to say the reflection, rotation, translation, or enlargement. Now it's not gotten any bigger, so it's not an enlargement. It is also, like, the orientation of it has changed, so it is not just a translation either. And basically what the idea is it's spun around a particular coordinate. Now this is not the easiest thing in the world to do without tracing paper, but I think the center of rotation very much looks like it's here, doesn't it? So that has spun round, that has spun round. So this is where a bit of tracing paper, you'd be allowed that in the exam. So this is a 180-degree rotation, and you don't need to say clockwise or anti-clockwise because it's 180 degrees around which coordinate? -1, 1. Just double check that, because again it's not the easiest thing to do on a computer screen. Rotation 180 degrees -1, 1. Super. Okay. Now this is the transformations and stuff. That's something that we will definitely be doing some more practice of, because you will always get questions like this. When it's a single transformation, you can't you can only say one type of transformation, so you can't say, oh, it was reflected and then reflected again, because that's 2 transformations. You got to only say 1. Right, number 13. A machine part is made by cutting a small square from the center of a large square piece of steel. Right, so the dimensions of the machine part are shown on the diagram. All measurements are in centimeters. So they're both squares. So you can see the big one is 3x add 4, 3x add 4. So they're the same. So yeah, 3x add 4, 3x add 4. And then the little square in the middle, x add 4, x add 4. So straight away it looks like that's x. Although no, that's maybe not the right way to think about it. I think the idea though is certainly the difference between them is 2x. So clearly that's going to be a bit smaller if x is positive. Anyway, I think I'm rambling now. Let's get back to actually reading the question. The perimeter of the small square is 2/3 of the perimeter of the large square. And then we have to work out the length of a side of the small square. Okay, so we're going to need to figure out what x is and then add 4 to it. Okay, so let's just make a note of that. We need to figure out what x is, and then we need to add 4 to it, right? Because that's one side of the small square. Okay, so that's the end goal. So let's work out what the perimeter of the small square is. So the perimeter of the small square is, well, it's 4 lots of x plus 4. Right, that's how many there are. You could also say it's x plus 4 add x plus 4 add x plus 4 add x plus 4. But you're going to get the same answer if you do that as what I've written. You're going to get 4x altogether plus 16. So that's the perimeter of the small square. And then for the large square, so the perimeter of the large square is, well, it's 4 lots of 3x add 4, which is 12x add 16. Okay, so we will get some marks for that, I'm quite sure. So what does it say? It says the perimeter of the small square is 2/3 of the perimeter of the large square. So of means times, so I'm just going to write 4x add 16, because that's the perimeter of the small square. So the perimeter of the small square is, so that's the is, 2/3 of, which is going to be the times, and then the perimeter of the large square. So the perimeter of the large square, so let's make sure that's in brackets, 12x add 16. And then this is the equation we're going to solve. Right, so first thing to do is we got this 2/3, which is obviously pretty horrible, right? So how do you get rid of this division by 3? That's what we're doing. At the moment, we've got some division by 3 going on. So we're just going to times both sides by 3. So I'll have 3 lots of 4x add 16 is 2 lots of 12x add 16. Let me continue this over here. So let's expand that out. I've got 12x add 48 is 24x add 32. So take away 12x and take away 32 gives us 16. Because 32 add 16 is 48 is 12x. And so therefore x is whatever 16 over 12 is. Divide top and bottom by 4, so you get 4/3. And I've got to add 4 to that. So what's that? 4/3 add 4, so that's 1 1/3. Add 4 is 5 1/3, so 5 1/3 is my final answer. Let me just double check what it says in the mark scheme. It literally says 5 1/3 as a like it says mixed number 5 1/3. You could have written 5.3 recurring or something like that if you want. But that's the answer. Okay, so let's just recap what did I do there, because this is quite tricky. So I've got the perimeter of the small square, I've got the perimeter of the large square, and then I read that sentence and form an equation from it. So 4x add 16 is 2/3 of 12x add 16. I times both sides by 3 to get rid of this 3 here. I expand the brackets out, so I get 12x add 48 is 24x add 32. Take off 32 and take off 12x and divide. Now that's what x is. So x is the number 4/3, which is 1 1/3. And then it says, okay, we'll work out the length of a side of the small square. Well, that's not just x, is it? That's x plus 4. So I've got actually altogether for the answer 5 1/3 rather than just 1 1/3. Anyway, let's move on. F is inversely proportional to the square of x. So let's write straight away what this actually means. This is something we've learned about. So this means that F is k divided by the square of x. If it wasn't inversely proportional, it would be k times x squared instead of k divided by. Okay, so this is our little equation. Straight away, that's what you should write down for inverse proportion. If y is inversely proportional to z, you would write y equals k divided by z. If it was t cubed is inversely proportional to r squared, you'd write t cubed equals k divided by r squared. It's all to do with either k divided if it's inversely proportional, or k times if it's just normal proportional. Like it would just say proportional, or it might say directly proportional. If it was going to be k times instead of k divided. But in this situation, it is indeed k divided. So let's do the substitution to work out what k is. So f is 0.8. I'm going to try and figure out what k is. That's the idea. And x is 5. So what do you think you have to do to work out what k is? Well, I'm just going to times both sides by 25. So 0.8 times 25 is going to be k. So let's figure that out on the old calculator. 0.8 times 25 is 20. Could have done that in my head actually, because that's 4/5, isn't it? So that's 20. So the formula is f equals 20. And now for my final answer, I'm going to write it like this, right? 20 divided by x squared, okay? And then it says, okay, work out the positive value of x when f is 320. So I'm going to substitute into my formula. 320 is the f number, and this is 20 divided by x squared. So let's, we don't like dividing by stuff, so let's multiply both sides by x squared. So I get 320 x squared is 20. Now let's divide by 320 to get what x squared is. So you should be quite used to this by now. The idea that if we want what x is, we want first of all what x squared is so that we can square root at the end. So 20 divided by 320 is a 16th. And then x is going to be the square root of this, which is a quarter. Technically it's plus or minus a quarter, right? Because either, I mean, let's just do it. If I have a quarter and I square it, I get a 16th. If I have negative a quarter, well, a negative times a negative is a positive, so it's plus or minus a quarter. You should try to remember that from when we've looked at quadratics before. You've got this plus or minus thing going on because negatives square to become positive. But it wants the positive value of x. That's what it wants. It wants the positive value. So that's why we're just going to write a quarter as our answer. Okay. Right, next one. We're nearly there. How long's the video? Where does it tell? Oh goodness, we're nearly at 50 minutes. Well done if you've got to this point. Anyway, DC is 7, CB is 5, and the angle is 40. and we want the area of the parallelogram. Okay, well the area of a parallelogram is base times perpendicular height. Okay, so right off the bat. So I've got 7, so this is 7 times something, right? We don't know what the something is. We need to figure out what this height is. But we have an angle, right? We have an angle, so that's going to help us out. In fact, one thing you could do, well, you could either use this triangle that's going to be over here. I mean, it's upside down, so maybe people don't like that. Is you could use the fact that in a parallelogram, the angle over here is going to be 40 as well. Don't worry, because what I'm about to do is I'm going to use SOHCAHTOA, that's the idea. So you could just do it in this triangle. But I'm going to remind you that opposite angles in a parallelogram are equal, so I'm going to use it as a teaching opportunity, right? So here I've got 40, this will be 5, and I'm literally trying to work this out. So if I call this H, then what I've really got is, we're trying to figure out what H is, aren't we? Because if I know this, then I can get the answer to my question. H for height. So let's label the triangle ready for SOHCAHTOA, but we've done so much practice on SOHCAHTOA, you can maybe tell already what we're going to be using. So the hypotenuse is 5, the opposite is this perpendicular height, and then the adjacent, yes, it's here, but maybe by now we can tell we're not going to use this. So for this question, so we are going to use SOHCAHTOA to get this. We're going to identify that we're using SOH because we've got the opposite in the hypotenuse. So I'm going to write sine theta is opposite over hypotenuse, which in our question is h over 5. Okay, and the angle is 40. So I've got sine 40. Oops, trying to draw a degrees symbol. Let's do it more carefully. There you go. Sine of 40 degrees is h over 5. So it's going to tell me that h is 5 times sine 40. So let's do that. 5 times sine 40. Make sure I'm in degrees. Make sure you're in degrees. So 3.21 blah blah blah. And I need to times that by 7 to get my final answer, right? Because I've really got 7 times that. So 22.497, etc., etc. It wants it though to 1 decimal place. So that's going to be 22.5. So final answer. Look at that. We just check. I mean, I'm pretty confident, right? But I don't want to make a silly mistake in the video. 22.5. Right, great. What was the previous answer? Did we check that one as well? Yeah. Right, good. Okay, Clive wants to estimate the number of bees in a beehive. He catches 50 bees from the beehive. So we don't know how many bees there actually are, right? Like very first sentence, he wants to estimate the number of bees in a beehive. So we're going to call this number B is going to be the number of bees in the beehive. It's a relevant part of the question, right? It's literally what we're going to try to estimate. So B is the number of bees in the beehive. He catches 50 bees out of this beehive. That's going to be 50 out of B. It's a good choice of letter for this question. And what he does is he marks each bee with a die. So he puts a little, I don't know what he does, he marks them somehow. And then he lets them go and they'll fly back to the beehive. And then they'll go and they'll mix and mingle and spread themselves around the beehive, and it'll all be random again next day. So what happens is he goes and he catches 40 bees in the beehive. Now some of them some of them that he catches have the die on them. 8 of them do. Right, it says that 8 of them out of the 40 that he catches the next day have been marked with the die. Now, of course, unless he really only had 50 bees to begin with, they're going to have mixed and spread themselves out. So he's very unlikely to go and get all 50 for all 40 of his bees to have the die on them. So actually what's happened is they've all spread themselves out, and he's actually got 8 bees out of 40 that have the die on, and then 32 bees that he didn't catch the previous day that don't have any die on because they weren't caught that first day when he was doing the marking. So then the question says, right, given all this information, work out an estimate for how many bees there are. So this is us. We need to estimate B. Maybe B was not a good choice for this because it might get confusing. But I'm going to stick with it. So we're going to estimate the number of bees that are in the beehive. So this is how you do this. So if you ever get a question like this is how you do it. Okay. So what did Clive do? Well, he caught 50 bees out of how many bees he started with. So that's the proportion that he caught and marked, isn't it? He caught 50 out of B. And then, and this is where the second question comes in, right? We're going to assume that the bees went back and mixed randomly. Right, they weren't 50 bees who were all best friends who all, went and hung around in one area of the beehive. Like, they spread themselves out so that it was kind of very random when he comes the next day to collect 40 bees. So the bees went back and mixed randomly. And also there's one other thing we're assuming is that the population of bees doesn't change. Okay, we don't want any of these 50 bees to die. We don't want there to be anything that happens to the population of these bees overnight, because we want this to be a really good estimate. So the population stays the same. Now, why are these two assumptions important for what I'm about to do up here? So we caught 50 out of B, where B is the total number in the beehive. And the idea is we're going to assume that this is equal to when he catches 8 marked bees out of 40. That's the idea. 50 marked bees out of the total number in the beehive. The idea is that we're estimating this to be 8 out of 40, because he goes and he gets a sample of 40. 8 of them are marked. So this is really the key thing here. These are the idea is both of these are supposed to be the proportion of bees in the beehive that have die on them. On the left, we actually have the 50 bees that were marked out of the total population, and on the right, his estimate of this being 8 out of 40 the next day. And he's assuming these are equal based off of these things here, these two sentences. Okay, so we just need to figure out what B is. So, I mean, maybe it's a good idea if instead I make this say X, right? So X is the number of bees in the beehive. I thought it was going to be a good idea, but I actually regret choosing this now. But don't worry if you've been following along. So X is the number of bees in the beehive. 50 out of X is the proportion of those that are marked. Like, literally there are 50 out of X that are marked. And the idea is we're saying that's the same as 8 out of 40, because when he goes the next day and catches 40 of them, 8 out of those 40 have been marked. So we're just going to solve this equation essentially. So there's a few ways you could do this, right? You could use equivalent fractions. So for example, and there's lots of things you could do, but 8/40ths is the same as a fifth, which is the same as 50 out of what? Right, like this is the idea. 8/40ths is a fifth, times top and bottom by 50. So x needs to be 250 then, right? That's the idea. The idea is there must be 250 bees in the beehive. We will do some more, we'll do practice questions like this in class, but I thought might show you this now. Right, number 18. Write as a single fraction in its simplest form 2 over x minus 4, 1 over x plus 3. Okay, so we actually have done this in class before. This is algebraic fractions. Now I'm just going to show you a little example with normal numbers. So here's a little example. So if I have, for example, 3/4 take away 2/5, right? Let's say take that for the sake of argument. What is it we need when I'm adding or subtracting fractions? Well, we need a common denominator, and we get that by finding a common multiple of the denominator. So we'd have a common multiple of 4 and 5. Now we can choose 20. We can do, because we can do 4 times 5. We could have 40. They're both that's in the 4 and the 5 times table, etc. Now the easiest way of doing it is to literally do 4 times 5. So I'm going to sort of write this out a little bit kind of long-winded, and I'll show you what I mean. I'll change my color here. So here I've got on the top 3. I've got to times top and bottom by the same thing, and over here I times top and bottom by 4. Now, normally you wouldn't write that step in, would you? You would just do it straight away. You'd have 15 on the top. So you get your answer on the top, you get your answer on the bottom, get your answer on the top, and your answer on the bottom. And then you just do the top take away the top, you take away the numerators, right? So 15 take away 8 is 7. So you get 7 over 20, right? So we're going to use a similar approach to this one. Okay, so here I got 2 over x minus 4 minus 1 over x plus 3 equals, so let me write it 2 and then make this quite long. X minus 4, I'll write it there just like that for now, minus 1 x plus 3. Now notice what we did over here. We just took the denominator of the other fraction and times top and bottom. So here for this one I'm going to times top and bottom by x plus 3. Just one moment. Sometimes this seems to crash a little bit, but then it seems to recover. So what's the idea? I'm finding a common denominator, and to do that, the denominator is going to have some algebra in it. Like, we just have to accept that. But the working is actually the same. Okay, so it's recovered, but is this going to work? Yeah. Okay. Right. It's sorted itself. Well, that's too big. I don't want that. Okay, 2 lots of x plus 3. Sorry about that, technical difficulties. I'm timesing the whole of the bottom with the whole of the bottom, so that goes in brackets. And I've got 1 lot of x minus 4. And then I'm timesing top and bottom by x minus 4. Okay, so if you actually write something that looks like this, you've already got a mark. Okay, you've already got a mark. Now, it might look pretty horrible. But it doesn't actually ask you to expand the bottom. It doesn't ask you to expand the bottom. So the bottom, you can just leave it factorized. Okay, you can just leave it factorized. Now, if you don't want to leave it factorized, that's fine. Now, you could expand that out. That's just going to give, that's a quadratic. You know how to do that with a grid method. But here, I'm going to have 2x plus 6. And I'm taking away, so let me just ignore this bit for now because I'm going to have to do some more working out. And then on over here, I've got x minus 4 over, let me write them the other way around so we are looking like we've got the same denominator, because it doesn't matter what order your times in, so I can swap them around. So we've got the same denominator now, x minus 4, x plus 3, and on the top I've got 2x plus 6. I'm taking away an x and I'm taking away a negative 4. So that's going to be taking away negative 4 is the same as where you go up the number line by 4. So I'm going to write plus 4. And then equals 2x take away x on the top is x and 6 add 4 is 10. So you get x plus 10 on the top over x minus 4, x plus 3. And you can just leave the answer like that, okay? Let's just check the answer to that. X plus 10 over x minus 4, x plus 3. Yes, super. If you did expand it out, it's x squared minus x minus 12. Right, then we've only got one more question. So it's a probability tree question. So we've taken 2 random suites. So let's just draw the probability tree. Let me actually make this a bit smaller to start with. So hopefully you know what the question is. Can I crop that as well? Crop, get rid of this. Oh, wow, there you go. Okay. So I've made that really small because I'm going to need a lot of room, okay? You might want to go back and pause to actually see the question, but you should also have the question also like in front of you, I would say. So anyway, we've got probability tree where we've got fruit, aniseed, and mint. And then we've got fruit, aniseed, and mint. Now, I already want to save myself a little bit of hassle. Work out the probability that the 2 suites will not be the same type of suite. So I don't actually need to draw the branch that goes FF, for example, because I'm not actually going to be using that branch, am I? That's not going to form part of my answer. So let me just, I mean, you can save yourself a bit of time in general by reading the question ahead of time. If you did draw the entire probability tree, well, you would just have some branches on it that you didn't end up adding up for your answer. I'm just going to do this so that I don't have loads and loads on the screen. So I've got F and then A and then M. A, F and then M, and then M, F, and then A, okay? So the probability of getting a fruit suite, so this is like the first suite, so this is the first suite, and this is the second suite. So all of these are going to be out of 30. Because we've got 30 suites to start with. So this is 18 out of 30. That's 7 out of 30. And that's 5 out of 30. And now, once we've taken a suite out, we've now got 29 suites left to take our second suite from. So the numbers on these branches are all going to be out of 29. Now remember, you were as a class, were pretty good at this by the end, realizing that you'd have to knock 1 off the denominator. And now we just have to work out what the numerators are. Well, if I started by taking a fruit sweet, I still have 7 aniseed and 5 mint. If I started by taking an aniseed, then I still have 18 fruit and 5 mint. And if I started by taking a mint, well, there would still be 18 fruits, sweets, and 7 aniseed sweets. And so we've either got FA, FM, AF, AM, MF, or MA. And if you remember, how do you do these? So you do 18 30ths times 7 29ths. You'll have 18 30ths times 5 29ths. Now, of course, in the exam, I'm just writing this out to illustrate it. You could have done this without writing this particular part down. You could just do the calculation. You multiply as you go along the branches. That's the idea. So 5 30ths are times 18 29ths, and 5 30ths times 7 29ths. And then I'm actually gonna, add all these up. So you add as you go down. So let's bring so the calculator's already up. Great. So we're gonna do this. This is a bit annoying. There is a shortcut to doing this. In the sense of I could just do 30 29ths out the front and then do 18 times 7, 18 times 5, 7 times 18, blah, blah, blah. But I'm going to do it like this just to show you. So that's the first one. 18 30ths times 5 29ths plus 7 30ths times 18 29ths plus 7 30ths times 5 29ths. And now do you see when that kind of square like that appears on the calculator, it means it's running out of memory, it's running out of room. So you want to, at this point I would press equals. I would realize I'd gotten up to this one, the AM one. I'd press equals, and then I know I've still got to add 5 30ths times 18 29ths. Add, and then 5 30ths times 7 29ths. Okay, so what's that? Well, let's write the answer. So 251 out of 435, that's the answer. And that will be a good time to check the answer, I think. Does that answer 5, or it's got the answer 502 over 870, but that should simplify to 251 over 435. Great, so that's correct. Oh, I've just noticed the calculator's in the way. Let me move that. So 251 over 435. Right, and then that's the entire calculator paper there done. I mean, there would have been extra questions. I mean, in real life, a few of these questions that I've gone through, you would not take as much time as I did because I was explaining them. But I'm hoping that that's been useful. These videos will get better as I get better at using the various bits of software and the various things that I've got here. So yes, hopefully this has been useful. Leave a like if it has, and I will see you next time.